Welcome to Pod AI Cast _official.
Great to be here. Today, we're doing a really important deep dive, I think. We're digging into something that's, well, fundamental for anyone building serious systems in the cloud.
Absolutely. We are tackling the AWS well-architected framework the way. It's basically the blueprint, the foundational guide for building systems that are resilient, secure, efficient, all the good stuff.
And our mission today, it's not just to list the points. We want to go deeper. We want to give you, our listener, a really clear, practical understanding of the best practices, sure, but also the thinking behind them, those 6 key pillars.
And critically, the role of the person who has to juggle all this solution architect.
Yeah.
How do they actually use this framework day to day?
Right. Because it's complex. So we're pulling directly from the way of materials themselves. We'll look at the design principles, the best practices for all 6 pillars, and even things like documentation standards, ADRs, architectural decision records.
Yeah, ADRs are key.
Understanding these sources, it really means getting the intent behind these cloud best practices, why they exist.
And let's be super clear up front about what the WAF is.
Yes.
Sometimes people think it's like an audit team coming to wrap your knuckles.
Yeah, definitely not.
It's designed to help you understand the trade-offs, right? The pros and cons of the choices you make when you build on AWS. It's about making sure your workload is secure, reliable, performs well, doesn't cost the earth, and now is sustainable too.
It's explicitly positioned as a tool for constructive conversation, and its origins give it, frankly, massive credibility. These aren't just academic ideas dreamed up somewhere.
This is hard-won knowledge.
Exactly. These are the codified best practices learned from AWS, running literally thousands of systems at massive internet scale. It's formalized, backed by data, and critically, vetted by top-tier experts like principal engineers, the people who actually enforce these standards internally at AWS.
So it's basically institutional knowledge packaged up for the rest of us.
Pretty much, yeah, that's a good way to put it.
Knowing it comes from the folks who keep large parts of the internet running, that definitely adds weight. Okay, let's start unpacking this framework. So the DoEF is built on these 6 interconnected pillars, and they cover a huge amount of ground, everything from how you operate day to day, your financial strategy, technical resilience, even environmental impact now. It forces a holistic view.
That holistic perspective is absolutely the key takeaway. Architectural maturity isn't just picking the right database, is it?
No.
It's making sure your operational choices support your budget and your security posture doesn't kill your reliability. The pillars are designed precisely to stop you from just focusing on one thing, like speed, while ignoring cost or security implications. You can't optimize in a vacuum.
Okay, so let's quickly name these 6 pillars, just define the territory.
Sure. First, operational excellence, OPS.
Okay.
That's about running and monitoring things effectively.
Then security, SEC, pretty self-explanatory, protecting your stuff.
Reliability, REL, can the system recover when things inevitably break?
Performance efficiency, PERF, using your compute resources wisely.
Cost optimization, COST, avoiding spending money you don't need to.
And the newest one, sustainability, SUS, thinking about the long-term environmental footprint.
And what makes the framework really powerful and scalable across big organizations is the consistent structure within each pillar.
I think so.
Well, for every single pillar, you get the core design principles, that's the mindset you need, then a clear definition, then specific measurable best practices, and finally, resources like which AWS services help you achieve that best practice.
Okay. So it's very structured.
Incredibly consistent. That consistency is kind of the secret sauce. It lets huge global companies adopt and apply the WAF uniformly. Everyone speaks the same language.
Now, the review process itself, this is where I think people sometimes get bogged down. They imagine weeks of painful meetings.
Right. But the WAF itself says, no, no, no. It should be lightweight. We're talking hours, not days or weeks. And it has to be consistent, constructive, and this is crucial, absolutely blame-free.
That blame-free part seems really important.
It's fundamental. If people are afraid of the review, they'll hide the real issues, the tricky trade-offs they made.
And then the review is useless.
Totally useless.
Right.
The entire point is just to identify risks, flag potential architectural problems, and figure out clear, actionable steps to improve. The best practices are conversation starters, not a scorecard to fail people with.
Okay, so it's more about continuous improvement.
Yeah.
Which leads to the recommendation that teams shouldn't just do this once a year, right?
Exactly. Relying on a single snapshot in time is kind of pointless. The architecture is always changing. When you deploy a new feature or swap out a component, the team building it should ideally be updating their WAF assessment as they go. keep it alive.
A living document almost.
Yeah. So you maintain that architectural quality alongside your delivery speed. And even if you do have a more formal review session, the guidance suggests making it conversation-driven first.
How does that work?
You try to get the answers to the WAF questions through informal discussion. Talk to the team. Only if that conversation reveals big gaps or risks do you then need to do deep dives into documentation or logs. It builds trust in the process. It's not an interrogation.
All right, let's dive into the first pillar. Operational excellence, or OPS. You called it the engine room earlier. It's all about running and monitoring systems effectively and always improving how you do it.
Yeah. OPS is where the rubber meets the road. It translates that high-level vision from leadership into repeatable, quality execution by the teams. And it starts with the right mindset, laid out in the design principles.
Okay, what's the first one?
Foundational. Organize around business outcomes. This means leadership must be bought in. They need to invest in a proper cloud ops transformation with an operating model that aligns everyone's goals, their KPIs, their incentives right across the company.
That alignment sounds critical. Like if dev is rewarded only for speed, but ops is punished only for downtime?
You've got built-in conflict. The WAF insists everyone, from the top brass down to the engineers pushing code, needs to understand how their specific work connects to the real business goals, like reduce customer churn or increase checkout conversions, not just deploy 50 servers.
Makes sense. What's next in the OPS mindset?
Visibility. Implement observability for actionable insights. And we need to unpack observability a bit because it's more than just basic monitoring.
Right, it's not just CPU alerts.
No, it's about getting a complete picture performance, reliability, cost, system health by combining different types of telemetry data, specifically the big three metrics like CPU, logs, event records, and traces following one request through multiple services.
Okay, so logs, metrics, traces.
You combine those, and teams can then make proactive decisions. You move from reacting to server X is down to seeing, say, a slow rise in latency in microservice A and fixing the underlying database query before users even notice a problem. That's the leap from monitoring to true observability.
That proactive element is huge, and I guess it leads naturally into automation.
It does. Safely automate where possible. Treat everything as code, infrastructure, config, procedures, apps. That's infrastructure as code, or IAC. Automation cuts down massively on manual toil and, importantly, human error from repetitive tasks.
But you can't just automate everything recklessly.
Absolutely not. Automation needs safety controls. You need guardrails, automated checks, boundary policies. You need rate controls, error thresholds, maybe approval steps for critical changes. The goal is to reduce toil, not automate a catastrophe.
Which brings us to a really big cultural shift the Wave pushes for. Make frequent, small, reversible changes.
This is transformative for both speed and stability. If you design your system with loosely coupled parts and deploy small incremental updates, you drastically shrink the blast radius if something goes wrong.
So if the small change breaks something,
You just quickly roll back that one small isolated change. Compare that to the old Big Bang deployment months of work, thousands of changes all deployed at once. If that fails, it's a nightmare. Huge blast radius, complex rollback. Small, frequent changes build confidence and let teams deliver value faster because the risk is managed.
okay, beyond the tech and process, OPS also talks about culture and clear roles.
Yes, clarity on roles. OPS here too. The source material is very direct here. You must have identified clear owners for every single application, workload, process, procedure, no ambiguity.
Why is that so critical?
Think about it. Database is slow, who owns fixing it? Deployment pipeline breaks, who has the authority to stop the release? When responsibilities and ownership are clear and easy to find, it cuts down on so much organizational friction and confusion. People know who to talk to, who can make the call, especially during an incident.
And this links to the idea of embracing failure.
Exactly. Fostering a culture of experimentation and failure. Leadership has to set the expectation. Failures will happen in complex systems. It's unavoidable. But they're learning opportunities. They need to differentiate between one-way door decisions, big irreversible choices, like picking a core database tech, and two-way door decisions.
Which are smaller, easily reversible choices.
Oh, yeah. And you empower teams to make those two-way door decisions themselves, decentrally. If they know they can easily undo a small change, they're much more likely to experiment and innovate. The key is giving people the power to act when needed, but also the tools and documentation like tested runbooks to do it safely.
There's a good example in the source material, right?
Yeah.
Any company retail.
Yeah, it illustrates this journey well. They started with manual, step-by-step run books, literally guides you had to follow. Prone to error,
Oh,
slow.
we've all seen those.
Over time, they matured. They turned infrastructure setup into IAC using CloudFormation or CDK. But crucially, the operational procedures themselves became code to automation documents in Systems Manager, or Lambda functions.
Ah, so the runbook became the automation.
Exactly. Processes became repeatable, version controlled, ownership was tracked with tags, documentation lived alongside the code, maybe auto-generated. They moved from manual checklists and potential errors to codified, reliable operational excellence. That's the goal.
Okay, let's shift gears to the security pillar, SEC. We've got the engine room running smoothly with OPS, but it's useless if the ship isn't secure. The core idea here is aligning security controls with compliance needs and enforcing them constantly, ideally through automation.
Right. And the first big strategic idea in security, often the most impactful, is actually about reducing your workload,
Right.
minimizing your security management scope. This is best practice, SEC 01 BPO5. It ties directly into the shared responsibility model.
Okay, quick refresher on shared responsibility in this context.
Sure. AWS handles security of the cloud, the physical data centers, the core network, the hypervisor. You, the customer, handle security in the cloud patching operating systems, configuring firewalls, managing application code, securing your data.
So the best way to reduce my security burden.
Is to use managed services wherever possible. This is key. Instead of running your own database server on an EC2 instance where you have to patch the OS, manage backups, configure security groups at that level.
You use something like Amazon RDS, the managed database service.
Exactly. With RDS, AWS handles the OS patching, the underlying infrastructure management, the basic setup. You instantly reduce your attack surface and the sheer amount of security work your team has to do. It leverages AWS's expertise for those lower layers and often lowers your total cost of ownership, TCO too.
Makes sense. The sources also heavily push integrating security into development pipelines, right? CI/CD.
Massively. Define your security controls using infrastructure as code, CloudFormation, Terraform, whatever, and bake them into your automated deployment pipelines. This ensures that standard controls, like maybe using a central identity provider or specific logging configurations or network rules, get deployed consistently every single time, especially across multiple accounts managed with AWS organizations.
Automation seems to be the only way to scale security effectively.
It really is. They even mention specific tools like AWS CloudFormation Guard. You can use that to check your IAC templates for misconfigurations before anything even gets deployed.
Ah, shifting security left. Catching problems early.
Exactly. Finding a security hole in the code or template is way cheaper and safer than finding it in production. But automation isn't just preventative, it's also about reacting. Automated remediation, SEC Euro 4 BP04.
So automatically fixing things that go wrong.
Yes. You define programmatic steps, maybe using AWS Systems Manager documents or Lambda functions, to automatically correct resources that services like AWS Config or Security Hub find to be non-compliant.
Like if a security group accidentally gets opened up to the world.
Perfect example. The automation detects it via config rule, triggers a Lambda function, and that function immediately corrects the security group rule. Consistent, prompt action.
But there's a big but here, isn't there? The WF warns about the danger of automated remediation.
Absolutely. If your automated fix is flawed, or closes a port that's actually critical for business, well, you've just automated an outage, maybe a really bad one.
So tread carefully.
Very carefully. Automated remediation needs rigorous testing, version control, and strong oversight mechanisms to ensure the fixes are correct and don't cause unintended consequences. You need guardrails on your guardrails, almost.
Okay, let's talk identity and access management, IAM. This is always huge. What's the core message from WAF here?
Unambiguous. Temporary is better. Use temporary credentials whenever possible.
Meaning IAM roles.
Primarily, yes. Assign IAM roles to your compute resources, EC2 instances, Lambda functions, containers. These roles automatically get short-lived temporary credentials. Avoid long-term access keys for users or applications if you can possibly help it.
Why are long-term keys so bad?
Because if they leak, they're valid potentially forever or until someone manually rotates them. That's a huge risk window. Temporary credentials from roles expire automatically, often within hours, dramatically shrinking the opportunity for misuse if they're compromised.
And this goes hand in hand with the principle of least privilege.
Definitely. Only grant the absolute minimum permissions necessary for a user or service to do its specific job. And implementing this isn't a one-time thing, it's a constant process of refinement.
How do you refine it? It sounds hard.
It can be, but you can use data. Analyze the actual API calls a service makes using logs from CloudTrail. Or even better, use tools like IAM Access Analyzer, which can analyze those logs and generate a least privilege policy for you based on actual usage.
Oh, that's useful.
Very. And you must review permissions regularly. Prevent that slow drift where old, overly broad permissions just hang around forever. That's permissions creep.
One last crucial point on access. Emergency access. Break glass scenarios.
Yes. This needs to be documented, tested, absolutely. But the golden rule is separation. Your emergency access mechanism, how your core team gets in during a major incident, must not depend on the same systems as your normal access.
So don't rely on your main corporate single sign-on if that system itself might be down.
Exactly. Or the same network path, or the same IMM roles even. If your primary identity provider is offline due to an outage or a security breach, your emergency break glass access must still work independently, so your team can get in and start fixing things. Resilience demands separation here.
Okay, moving on to reliability, REL. This is huge in the cloud. We're dealing with distributed systems, and the DOEF basically says, assume things will break. So designing for failure, tolerance, and self-healing is paramount.
Absolutely. And one concept that's fundamental here, but sometimes trips people up, is idempotency. REL OU04-B05. It's critical when network calls might fail and you need to retry.
Right. Explain idempotency simply.
It means making the same request multiple times has the exact same effect as making it just once. No harmful side effects from repeats.
Like the classic example, charging a credit card. If my request times out, did the charge go through? If I retry blindly.
You might charge the customer twice. Big problem. To make an operation idempotent, the client sending the request includes a unique identifier, an idempotency token, with each attempt of that logical operation.
Like a unique order ID.
Could be, yeah. Or just a randomly generated UUID for that specific transaction attempt. If the service receives a request with a token it's already successfully processed, it doesn't perform the action again. It just returns the saved result from the first successful attempt. Guarantees exactly once processing, even with retries.
Super important for financial transactions, order processing, lots of things. Okay, next big concept, static stability. This tackles a major anti-pattern.
It does. The anti-pattern is relying on dynamic actions, specifically control plane actions during an ongoing failure to recover.
What are control plane actions again?
The control plane is what manages your resources, launching new EC2 instances, creating databases, updating auto-scaling groups. The data plane is what handles the actual live traffic to your already running resources.
And the problem is,
During a major incident, like an availability zone failure, the control plane itself often gets overloaded or slowed down. Everyone is trying to launch new resources or change configurations at the same time. If your recovery plan depends on successfully calling those control plane APIs to launch new servers during the crisis, your plan is likely to fail when you need it most.
okay, that sounds bad. So static stability is the fix.
It's the preventative measure. The solution is to provision enough capacity statically across multiple availability zones, AZs, before any failure happens. The common example WAF uses is provisioning, say, 50% of your needed capacity in each of 3 AZs. That's 150% total capacity running all the time.
So if one AZ goes down.
The remaining 2 AZs, which are already running and part of the data plane, can instantly absorb 100% of the workload without needing to launch a single new instance via the control plane. You're relying on the stable, already running data plane, not the potentially fragile control plane at the critical moment.
Got it. That avoids what they call bimodal behavior, where the system acts totally differently under failure. Okay, what about controlling how services interact?
Crucial for reliability. First, throttling. You need to limit the rate of requests hitting your back-end services to prevent them from being overwhelmed. The source material visualizes this using the token bucket algorithm.
Explain the token bucket briefly.
Imagine a bucket that gets filled with tokens at a steady rate, your allowed request rate. Each incoming request needs to take a token to proceed. If the bucket is empty, the request is rejected or queued. The bucket also has a size, burst capacity, allowing for short bursts above the steady rate. Services like API Gateway use this to enforce limits.
So API Gateway acts like a bouncer, protecting my backend service from getting hammered by too many requests at once.
Exactly. And just as important as throttling incoming requests is managing outgoing requests, specifically retries. When your service calls another service and it fails, you need to retry intelligently.
Not just hammer it again immediately.
Right. If thousands of clients all retry at the exact same millisecond, they just create another massive spike and overwhelm the downstream service again. The best practice is exponential backoff with jitter.
Okay, exponential backoff means waiting longer between each retry 1 second, then 2, then 4.
Correct. But the jitter adds a small random amount of time to that delay.
Why the randomness?
It prevents synchronization. If 10,000 clients all fail and start backing off exponentially, jitter ensures the retry attempts are scattered randomly over the next few seconds, rather than all lining up precisely 1 second later, then 2 seconds later, etc.
Yeah.
It smooths out the retry load. A tiny detail, but massively important for system-wide stability.
All right, shifting to performance efficiency, PERF. The big message here seems to be make choices based on data, not guesswork. PERF 01 BPO7 says decisions need objective data from experiments and benchmarks. And there's always that trade-off triangle, right? Speed, security, cost, pick two.
Often feels like that, yeah. And this is super visible in data management for performance. You absolutely must choose the right tool for the job, the purpose-built data store.
What are the options?
WF lists them. Object storage like S3, block storage like EBS, file storage like EFS, traditional relational databases, RDS, various NoSQL options like DynamoDB, KeyValue, DocumentDB, Elasticache, in-memory. The choice depends entirely on your needs.
Like access patterns, random reads versus sequential scans.
Exactly. What throughput do you need? How often is data accessed? What consistency model is required? Strong ACID consistency for financial transactions, or eventual consistency for high-scale, less critical reads. Using the wrong data store, like trying to run a massive key-value workload on a standard relational database, will kill performance regardless of how big a server you throw at it.
Okay, so pick the right database. What about speeding up reads?
Caching. Use a multi-level caching strategy, maybe browser caching on the client side, plus a shared remote cache layer like Redis or Memcache using Elasticache, or maybe DynamoDB Accelerator, DAX in front of DynamoDB.
That gives you really fast reads for common data.
Tremendous efficiency gains. But you have to accept the trade-off. Every remote cache lookup is an extra network hop, adding a tiny bit of latency compared to hitting the database directly, if it were equally fast, which it isn't. You need to benchmark to prove the cache benefit outweighs that extra hop latency for your use case.
And manage the data lifecycle, too.
Yes. Don't keep everything in the fastest, most expensive storage forever. Use services like S3 Intelligent Tiering. It automatically watches how you access objects and moves less frequently accessed data to cheaper, slightly slower tiers, like S3 Infrequent Access or Glacier Instant Retrieval, saving you money without manual effort.
Smart. Lastly, network choices for performance.
Here, you're often trading off protocol features.
Okay.
Reliable ordered delivery with TCP/HTTPS versus potentially faster, lower overhead delivery with UDP/TLS for things like streaming or gaming, where occasional packet loss is acceptable.
And offloading encryption.
Ah, yes, a huge performance win often. Use SSL/TLS offloading at your load balancer, like an application load balancer, ALB. The ALB handles the computational expensive work of encrypting and decrypting traffic from the internet.
And then it sends plain unencrypted traffic to your back-end instances.
Right. This frees up CPU cycles on your back-end servers so they can focus purely on running your application logic, not crypto. The only reason not to do this is if you have strict compliance rules mandating end-to-end encryption all the way to the application server itself. Again, it's a conscious trade-off, ideally backed by data.
Okay, Section 5. Let's talk money and increasingly environmental impact. Cost optimization, COST, and sustainability, SUS. For many companies, cost is a primary driver for moving to the cloud, so this is always top of mind.
Absolutely. And the WF is really clear. Cost awareness and governance, COST 01 BPO4 isn't an afterthought. It needs to be baked into your culture and processes, treated just as seriously as security or operations.
It's a cultural shift for engineers needing to think about cost.
It really is. The cloud works on a consumption model. You pay for what you use. So the most basic, fundamental practice is eliminating waste. Stop resources you're not using, especially non-production environments.
Like dev and test servers.
Exactly. Shut them down during nights, weekends, holidays. It sounds simple, almost trivial.
But the savings add up.
Massively. Think about it. A typical work week is maybe 40, 50 hours. A full week is 168 hours. If you run dev tests 24/7, you're paying for over 100 hours of idle time per week, per instance. The sources mention potential savings of up to 75% just from this one practice. I've seen clients save huge amounts just by scheduling non-prod shutdowns. Pays for itself incredibly quickly.
Wow, okay, but to manage costs effectively, you need to know where the money is going.
Which brings us to attribution and decommissioning. You must use cost allocation tags consistently. Tag resources with things like owner, project, cost center, environment. Without good tagging, trying to analyze your bill or figure out who spun up that giant, expensive cluster is basically impossible.
Tagging discipline is key.
And tracking resource life cycles. COST04 BP01. Implement automated decommissioning. COST04 BP04. When a temporary environment, like for specific load testing, is finished, tear it down automatically. Don't let unused resources linger and silently drain your budget.
All right, let's talk pricing models. How do you get discounts for predictable usage?
Two main mechanisms: reserved instances, RIs, and savings plans. SCP-SPS visualizes how these apply.
What's the difference?
RIs typically offer the deepest discounts, but are usually tied to a specific instance family, operating system, and region for services like EC2, RDS, or Redshift. You commit for 1 or 3 years. Savings plans are more flexible.
How so?
Compute savings plans, for example, commit you to a certain dollar amount of compute spend per hour, say 10 hour, across EC2, Lambda, and Fargate, regardless of instance family, size, OS, or region. You get a good discount for that committed spend, offering more flexibility if your workloads change.
So RIs potentially deeper discount, SPS more flexibility, trade-offs again.
Always trade-offs. But even with these commitments for your baseline load, the guidance is clear. Still use on-demand instances for flexibility and spiky traffic. And critically, for workloads that can handle interruption stateless batch jobs, some types of data processing use Spot instances.
Because Spot offers huge savings.
Massive savings, often 70%, sometimes up to 90% off the on-demand price. You're bidding on spare EC2 capacity. The catch is AWS can reclaim that instance with short notice if they need the capacity back. So perfect for fault-tolerant workloads, not for your primary database.
Okay, one last cost area. Data transfer. The hidden killer.
It can be,
Yeah.
especially data transfer out to the public internet. The strategy is simple. Keep traffic within the AWS private network as much as possible. Use VPC endpoints for private connections to AWS services like S3 or DynamoDB from within your VPC.
So the traffic never hits the public internet.
Correct. It stays on the AWS backbone, which is usually free or much cheaper than paying public internet data transfer rates. This can save enormous amounts at scale.
Now, sustainability. It's the newest pillar, but its goals seem tightly linked to cost and performance. Use less, waste less.
Exactly. The core objective is simple. Use only the minimum resources needed for the job. Remove unused stuff. Optimize where things run geographically if it makes sense for energy mix.
And the key technical lever here is elasticity.
Definitely. Dynamic scaling, SUS02 BP01, is central. Use the cloud's elasticity EC2 auto-scaling, application auto-scaling for containers or databases to match your infrastructure supply precisely to the actual demand at any given moment.
So when demand drops, scale down automatically.
Right, an idle server is wasting energy and money. Scaling down aggressively minimizes that waste. It's good for the planet and good for your wallet. They're often aligned.
Architecture choices matter too.
Hugely. Efficient architectural patterns, like event-driven designs using Lambda or SQS, tend to lead to much more even resource utilization. Instead of big servers sitting idle waiting for requests, resources spin up just when an event happens and spin down afterwards. Much less idle waste.
And being smart about the hardware itself.
Yes. Continuously evaluate and choose instance types and services with the least environmental impact. This often means newer generations of hardware which are more power efficient.
Like using AWS Graviton processors.
That's a prime example cited. Graviton chips are ARM-based and designed by AWS specifically for power efficiency in their data centers, often offering better performance per watt compared to traditional by86 chips for many workloads. And again, using managed services helps here too.
How so?
Because it shifts the responsibility for the underlying hardware efficiency, the data center cooling, power sourcing, hardware lifecycle management from you to AWS. And AWS, operating at hyperscale, can generally achieve higher levels of optimization in their infrastructure than most individual companies running their own data centers.
Okay, we've gone through the 6 pillars in detail. Let's zoom out and talk about the person who needs to orchestrate all of this.
Yeah.
The solution architect, the SA.
Yeah, the SA role is incredibly challenging and critical. They're essentially the translator. They have to take high-level business needs, launch in a new region, handle Black Friday peak, meet this compliance standard, and turn them into concrete, balanced technical architectures.
Balanced being the key word, balancing cost, performance, security, reliability. All of those pillars we just discussed.
Exactly, and doing it within budget and time constraints. It requires this blend of deep technical knowledge, IT architecture, networking, databases, security, software engineering patterns.
But also strategic thinking.
Absolutely. Strategic thinking, strong analytical skills to evaluate options, and really crucial, excellent communication skills. They need to be able to persuade stakeholders, both technical and non-technical, why a certain trade-off is necessary, why maybe spending a bit more upfront on a more resilient design will save money and headaches down the road.
Making efficient decisions under pressure. And credibility is obviously vital.
For sure. This is where things like professional certifications come in. The sources mention the AWS Certified Solutions Architect certs specifically. They act as a validation that the person has the required technical depth and understanding of how to design effectively within that specific cloud environment. The SA is the one ultimately responsible for applying these weight of principles.
And applying them consistently requires good record keeping. Which brings us to architectural decision records, ADRs.
Yes. ADRs are so important for creating organizational memory. They're not just meeting minutes. They document the significant architectural choices. And the most crucial part is they capture why a decision was made, not just what the decision was.
Why is the why so critical? Can a new developer just look at the code or the infrastructure diagram?
They can see the what, sure. But they won't see the 3 alternative designs you considered and rejected. They won't understand the constraints, maybe a tight deadline or a specific compliance rule that forced a particular, maybe seemingly suboptimal choice. Without the why, future teams waste huge amounts of time revisiting old debates, reevaluating options that were already ruled out for good reasons. It prevents architectural amnesia.
Okay, so what absolutely has to be in a good ADR?
The WAF highlights several components, but 2 are non-negotiable: the rationale and the consequences. The rationale needs to detail the reasoning, the benefits of the chosen option, the drawbacks, the other options considered, the specific trade-offs made. For example, we chose DynamoDB for this service because we prioritize massive scale and low latency read-write over strong transactional consistency, which wasn't required.
Clear justification.
And
consequences.
This outlines the expected impact. What does this decision mean for the system, for the team, for other stakeholders? For example, choosing DynamoDB here means the downstream reporting system will need to handle eventual consistency, potentially showing slightly delayed data. Or, this requires the team to learn DynamoDB modeling best practices. It sets expectations.
And how should ADRs be managed? Just text files somewhere?
Ideally, no. They should be stored centrally, typically right alongside the code in a version control system like Git. They should be versioned themselves. And importantly, they should be treated as living documents reviewed periodically, updated if decisions change or consequences turn out differently than expected.
So they stay relevant.
Exactly. They become an invaluable tool for onboarding new team members, too. Instead of trying to track down senior engineers for hours to understand the system's history, a new person can read the ADRs and quickly get up to speed on the key architectural choices and the thinking behind them.
So we've covered a lot of ground. We've mapped out the DBO's guidelines for building mature, robust cloud systems. We went from defining roles and culture with OPS and SEC to engineering for failure with REL and PRF, and then managing resources smartly with cost and SUS. The DBF gives you the roadmap.
And the solution architect uses tools like infrastructure as code, observability, and these ADRs we just discussed to actually navigate that complex landscape and make the right trade-offs.
The framework's real strength seems to be not just the tech advice, but how it forces that focus on organizational alignment and culture.
Absolutely. And it explicitly calls out a major anti-pattern when organizations mandate a move to the cloud but don't set up a clear plan, budget, or sponsor for cloud operations itself.
What happens then?
Chaos, usually. Teams get crushed by technical debt, manual toil, unexpected costs balloon, and innovation just grinds to a halt because everyone's just trying to keep the lights on. It completely undermines the potential benefits of the cloud.
Right. So considering how much the WF stresses aligning teams around business outcomes, codifying processes, making data-driven decisions, here's a final thought for you, the listener, to mull over. What specific organizational structure shift might you need to push for in your own workplace right now to really unlock those cost and reliability benefits the cloud promises?
Is it creating a dedicated FinOps team to manage cloud spend? Is it finally breaking down the wall between dev and ops and creating truly unified product teams? Is it investing in a platform engineering team to provide those reusable guardrails and automation?
Think about that internal structure. The way it provides the technical best practices, the data is likely available. But sometimes the biggest architectural decision isn't about tech, it's about how your teams are organized to actually use that tech effectively.
Keep exploring, keep using data, keep refining those architectures.
Thanks for joining us for this deep dive into the AWS well-architected framework.